Okay, guys, good afternoon one more time. So now let's do some revision and finish this chapter, okay? And I really suggest you to practice at least 20 or 30 questions from exercise 1.3 and 1.4 as a preparation for your quiz, okay? And also after that, I will tell you when is the deadline to submit your assignment. So now, as you know, exercise 1.3, 1.4 is about lines and planes, and 1.4 applications. And these are the things we have studied so far, right? If you're given a line, how to write it is normal form and general form and vector form and parametric form. And how about planes in R3? Its vector form is n dot x equals n dot p. And also general form ax plus by plus cz equals c, and vector form is this. And also we obtain the formula, right? A distance from a point to the line or distance from a point to the plane. And for the plane, we did not prove this, but it can be proved in a very similar way. You see here, and also it's very similar. In plane, we are just adding one more term, right? So this distance from point B to the point L. So that is, let's say our L, right? And this is a point B, and that is the distance. Okay, we're talking about this distance. So this one is distance from point B to the line L. And also in a similar way, if we are given actually equation of the plane by this, that is ax plus by plus cz is equal to d. That is a general form of the equation of the plane, right? How do you find the distance from a point to the plane? So if you're given a plane and suppose that this is a point, it is b, right? Okay, so point, the distance means the shortest distance that is perpendicular to the plane, right? So that is the distance. How do you find this? That is ax sub 0 plus by sub 0 plus c sub 0. This x sub 0, y sub 0, z sub 0. It's the point, the coordinates of point B. And minus d over the length of this n, the normal vector. Now let's see a few examples. And in exercise 1 and 2, write the equation of the line passes through P with normal vector m in A and normal form and general form. And you already did this, okay? Again, since we're doing revision, let's just do only the second part, all right? And since P is passing through this one, right? What is the normal form of the line? That is n dot P is equal to, sorry, n dot x, right, is equal to n dot P. P is any point on the line. So at the time, the normal form will be, if we have 3, -4, and dots, and the components of x, these are vectors, right? It is x and y equals a normal vector. It is 3 and -4 dots, and p, any point on the line. So that is 1 and 2. Another example, in exercises 3 to 6, write the equation of the line passes through P with direction vector D in vector form and parametric form. Okay, again here, which one is this? Let's do the last question. So question 6. Okay, point P is given. So first it says the vector form. What is the vector form? You know that the vector form is x is equal to, here we have the direction vector, not direction vector. What is it? That is any point, right? Any point on the vector. And here we have plus t times d. That is the vector form of the line in R2. So since in 6p is given, d is given. So part A, it will be vector form, that is x equals p. So p is 3, 0, -2 plus t and times d. The direction vector is, what is it? 2, 5, and 0. Okay. So how about parametric form?
Right,
Parametric
yeah,
form will be
houses, educación.
the parametric form will be x equals 3 plus 2t, right? Y is equal to 0 plus 5t, that's just 5t. And the z component will be -2 plus 2, 0, that's just -2. Okay, that means our line is just lying 2 units down from the xy plane. Next question, in exercises 7 to 8, write the equation of the plane passes through P with normal vector M in normal form and in general form. Okay, and also here, let's just one of them. Let's do question 8. So what is it? A is a normal form. Normal form of the equation of the plane is, what is it? It is n dot x equals n dot p, right? So this equation gives us the plane. So what is n? N is given here 2, 5, 0. So it is 2, 5, and 0 dots, and x, let me just write it as x, y, z equals normal form is 2, 5, 0, 2, 5, 0 dots, and any particular point, so that is 3, 0, -2. And B, and how about the parametric or general form? General form will be, just we have to change this into algebraic equation, right? So that will be 2x plus 5y is z. On the right hand side, 2 times 3, 6 is 0 and 0, so that's equal to 6. Okay. So now you may wonder, Mr. Qasim, isn't it the equation of the line? Yes, it is the equation of the line in two-dimensional space. But here we are considering this where in three-dimensional space. In three-dimensional space, this 2x plus y equals 5, y equals 6. It is the equation of a plane. It's not a line. Another example, in exercises 9 to 10, write the equation of the plane passing through P with direction vectors u and v in vector form and parametric form. Again, here let's do for example 10. Okay. So first, vector form. What is the vector form of the equation of the plane? Vector form is x is equal to p plus s times u plus t times v, right? And what is the parameter equation of the line? As see here, it is the last one, right? This one is parameter equation. So we have to write this in this form. Okay. So using this one, what is it? The P is given, U is given, V is given, right? So the time this X will be P 6 minus 4, 3, 6 minus 4 minus 3 plus S times U. What is U? 0, 1, 1, 0, 1, 1, and plus T V, that is minus 1, 1, and 1. Okay. And B, how about the parameter equation? The parameter equation is x equals 6 minus t. And y is equal to minus 4 plus s plus t. And z is equal to -3 plus s plus t. So that is the parameter equations of the plane. Okay. In exercises 11 and 12, give the vector equation of the line passing through P and Q. So here, let's see question 12, the second question. So we are talking about the line. This one is point P, and this point is point Q. Okay. The question is, we have to find, what is this? The vector equation of the line. Now, what is the vector equation? A vector equation is x equals p plus d, right? So first, we just need a particular point and direction vector. So as a direction vector, we can just take this pq, right? This pq, and let's say this is our direction vector. So then what is the direction vector? Direction vector is pq So that's equal to -2 minus 0, it is -2. 1 minus 1, it is 0. 3 minus -1, it is 4. Okay, and let me just write it as PQ. All right, PQ. So now I'm just going to write the direction right in the more simplest form, because if you multiply this by any number, it just gives us another vector which is in the direction of this PQ. Since we just need its direction, right? So our direction vector will be, if you multiply this by -1/2, it will be 1 and 0, -2. It looks much simpler, right? So at the time, dot, the vector equation of this line will be any particular point. Let's say this P, 0, 1, -1, plus T times direction vector. That is 1, 0, -2. Exercises 13 to 14 give the vector equation of the plane passes through this P, Q, and R. Okay, so let's do 14 here. Okay, so we are talking about a plane. Okay, and suppose that this point is P, and this point is Q, and this point is R, right? And to write the vector equation, right, we need two vectors lying in the plane. So I can just say them as PQ and PR. Suppose the PQ is vector U, PR is vector B. Okay, so first I need to find these vectors. What is vector U? Vector U is PQ, vector PQ, which is equal to vector PQ, right? PQ is 1 minus 1, it is 0. 0 minus 1 is -1, it is 1. And how about vector V? Vector V is PR, PR. So that is PR, 0 minus 1, it is -1. 1 minus 1, it is 0. 1 minus 0, it is 1. Okay. So now we can write the general, what is the vector equation of this plane? Dot, that is x equals P plus S times U plus T times V. And yes, and T is any real number, right? Equals, what is vector P? Any particular point, that is 1, 1, 0. Plus S times U, that is 0, -1 and 1. Plus T, and here we have -1, 0, 1. Okay. Question 15. Find parameter equations and an equation in vector form of for the lines in R2 with the following equations. So which one shall we do? Let's do question B. Okay. So our equation is 3x plus 2y, that's equal to 5. Number one, vector form. What is a vector form? We need to write this as part A, right? Parameter equation, okay, parameter equation. So how do we write the parameter equation? Parameter equation means that we have to express this x and y in terms of t, right? So now it depends on you how you introduce your parameter. For example, if let's say if I introduce this one, let's say x is equal to t, at the time y will be equal to 5 minus 3x over 2, right? So at the time our parameter equation will be x equals t, and y is equal to 5 over 2 minus 3 over 2t. That's a parameter equation. And in a different form, actually, we can express this. We can take 3x as t, for example, or 3x something as t. It depends on you. Doesn't matter how you introduce. Of course, we have to introduce in such a way that it must make our calculation much easier. It must be in the simplest form. And how about the second part? It says second part is equation in a vector form, right? What is the equation in a vector form? That is the first part. The second part is equation in vector form is x is equal to p plus t times d, right? So that is the equation in vector form. How can I find P? P is any vector on the line. So this P will be, for example, if X is equal to 1, Y is equal to 1, it is on the line, right? And how about D? D is any vector that is parallel to the line. Parallel to the line means that, again, for example, let's say, if I just pick any 2 points, right? Any 2 points, let me just write here, that's our line. Let me just write a point P, okay, whose coordinates are 1 and 1. Another point is point Q. Let's say if X is equal to 2, it will be minus 1, not X equals 2. How about 5, okay, 11, 4, 12. Okay, so 12 minus, anyway, it doesn't matter. Let's say if X is equal to 2, 6 plus what number is 5? Negative 1. So Y must be minus 1 over 2, right? So this direction vector, right, it will be this PQ. 2 minus 1, it is 1. Minus 1 over 2 minus 1, that is minus 3 over 2. Or you can just multiply this by 2. I will get this as 2 minus 3. So let's say this PQ, okay, then our direction vector will be, what is it? Multiplied by negative 2, it will be 2 minus 3, okay? So at that time, this vector equation will be P is 1 and 1 plus T times D, direction vector is 2, negative 3. Okay. Maybe I will do, let me do one question. I think I will finish the class. That's much enough. And if you have any questions, but let me know. We can meet and practice some more questions together. Okay. Anyway, from next week, you're going to meet your TA. Find the vector form of the equation of the line in R3 that passes through P, negative 1, 0, 3, okay, negative 1, 0, 3, and is parallel to the line with parameter equations this. Okay, so suppose that this is the equation of L1, or let me just write here, L2. Okay, so what is the question? Find the vector form of the equation of the line that passes through this point and parallel to the line. So if our line is, let me just write here, this one is L2. So we are looking for another line that is parallel to this. Let's say this is our L, and which is passing through the point, it is P. Okay, so we need to find this. All right. So from the given equation, right, I can just write it as this L2 is this L2. This one is L2. Okay. So I can just write this X equals, here we have 1, 2, negative 2. Plus, and here we have T, negative 1, and 3, negative 1. Right? And as we remember, it's just in the vector form, that is vector P plus T times vector D, right? Now to be able to write the equation of a line which is parallel to this, that means that actual direction vector, it serves for both vectors. That's our direction vector, because since they are parallel, right? And particular point is given, right? So at the time it says vector form of the equation. So this L will be X, right? And P, the particular point is negative 1, 0, and 3 is passing through this point, plus T times D. What is D? D is the direction vector, that is negative 1 and 3 and negative 1. Guys, that's all for today. And we have some other recorded videos in the channel playlist. Also, you can watch this, or if you have any questions, you can share on Telegram, okay? And also we can have discussion or share the solution. And keep practicing until Tuesday. If you have any question related to this chapter, I will try to answer your questions, okay? On Tuesday, you'll have quiz. That's all. Thank you very much. Have a nice weekend. See you next week.
Goodbye, sir.
Goodbye, sir.
Bye. Thank you.
Bye, sir.
Bye bye.